There is always more than one way to get the wood and brush to the ground, but the best method is the one that maximizes productivity while still maintaining safety. An investment in equipment and education into the science behind the equipment can pay off by making the work easier, reducing wear on tools, and allowing larger sections to be safely removed. The first choice to be made is whether to run ropes through natural crotches or through a false crotch block. Natural crotches can be fast and effective, but the running rope can injure the tree, and the consistent friction and versatility of placement of false crotches are often great advantages. Just as important as how friction is reduced at the rigging point is how it is added to the rigging system when lowering larger pieces. Certainly, wrapping the rigging line around a tree trunk will work, but the amount of friction added is inconsistent, and the wear on ropes and trees can be excessive. Friction devices offer alternatives to these drawbacks with the additional ability to help in raising wood. Choosing an appropriate knot to tie off a section of wood can be important for large pieces or when dynamic loading will be a concern. One standard knot is the clove hitch. If unsecured, a piece can roll out of the clove hitch the same way a taut line hitch can roll, so a tail must be left in the working end of the rigging line and at least 2 half hitches tied around the standing part of the line. Another option for tying off pieces is the running bowline. The advantage of the running bowline is that the rigging line can be set in a distant crotch, the working end retrieved, and the knot secured to that crotch by pulling on the standing part of the line. As unsophisticated as it may sound, perhaps the most common technique in pruning is to cut a piece and throw it to a safe landing zone, drop zone, on the ground. Once ropes are employed, techniques are categorized by the position of the rigging point relative to the work. In cases where pieces are rigged from above and swing is controlled, security is still important, but ease of tying and untying can also be considered. With the rigging point above the work, most often the piece is tied at the butt end, cut, and lowered to the ground. This technique is appropriate in many situations and in day-to-day work may be all that is required. Controlling the swing is important for the safety of the climber and surrounding property. Sometimes it is not worth the time to piece out a large limb by butt tying several sections compared to removing one piece with a more complex technique. In these cases, still with the rigging point above, the piece could be tied at the tip and dropped or tip-tied and lifted. When the piece must be removed without dropping either the butt or tip, it can be tied so it is balanced, then lowered to the ground. With any of these techniques, a tagline can, and often should, be used to direct the fall of the piece or control its swing. A tagline is a second rope tied to the piece and controlled by a ground worker, but which does not support any of the load. There are situations where a rigging line cannot be anchored above the work, such as in removals after all the brush has been removed and the trunk remains. Most common in these cases is butt hitching, where a piece is tied above a cut and the line is run through a block or crotch below the cut. This can be one of the most demanding techniques for a rope because the possibility of shock loading is so high. Because there are no high tie-in points, it can also be dangerous for the climber. Most of the time, there are many methods for removing any given limb or tree in any site. Arborists call on their experience to choose the safest, easiest, and most efficient technique in each scenario. Some sites are so limited in space or maneuverability that removing branches from a tree will require a great deal of planning and experience, as well as ropes and equipment. Once an arborist has mastered the basic rigging techniques, however, equipment can be combined to create compound rigging methods that are designed for particular situations.
Once the limb is rigged for removal, the climber must decide on the appropriate method of cutting the limb. The drop cut, the classic 3-point cut, dates back to the early years of arboriculture and appears in almost every pruning text as the recommended technique for removing large limbs. It consists of an undercut and a top cut further out on the limb.
When using a chainsaw, arborists should form the top cut directly above the undercut to avoid getting the bar stuck in the kerf of the cut as the limb breaks free.
A cut that is handy for controlling relatively small sections of wood that may not require roping is the snap cut. This cut is made by cutting slightly more than halfway through a section from the side, then cutting from the opposite side, about an inch or more offset from the first cut. The distance apart will need to be larger for larger limbs. The two cuts will bypass, but the fibers should hold. The saw can then be shut off and the remaining piece broken off manually.
A variation of the snap cut can be used to remove the final stub from a large branch that has been removed. The hinge cut is a variation of standard tree felling techniques and is referred to as a topping cut when taking a vertical top out of a tree. It employs the use of a notch and back cut to form a hinge and steer the limb. It can be used to swing a limb around rather than simply dropping the branch to the ground. Unless the limb is supported with a rigging line, there is a limit to how much the climber will be able to swing the limb before the hinge breaks. If the hinge is formed too far around the side of the limb, the hinge may be ineffective and may break before the limb swings. The strategy for piecing out a tree depends on the circumstances. The climber must plan the order of removal to avoid being left with a limb that is too difficult or dangerous to remove. A general rule of thumb is to clear a pathway for the limbs, removing brush first. Removing the easiest limbs first can sometimes cause problems when trying to rig limbs later. As with all aspects of removal, the key to safety is to use equipment that can handle the load. Workers must avoid trying to take out a section that is too big and must always consider what could happen if some component of the rigging fails. The climber and all ground workers must be clear of danger in the event of something breaking unexpectedly. Rigging is the use of ropes and other equipment to take down trees or remove limbs. The simplest form of rigging uses ropes, wraps on the trunk, and natural crotches as rigging points. More sophisticated equipment and techniques are available. Be sure to understand the proper use of all equipment and familiarize yourself with applicable local, state, provincial, national, or federal government standards. Types of ropes used in arborist rigging include 3-strand, low strength, high elongation, inexpensive, appropriate to run through natural crotches. For climbing or rigging, also runs well through a false crotch. A major drawback of 3-strand rope is the twisting or hockling that occurs. 16-strand, braided arborist lines with relatively large cover strands for strength and abrasion resistance. Parallel core keeps the rope round and firm under load. In this construction, the core does not carry the load. Double braid, a rope inside a rope. The core and cover are balanced and share the load almost equally. Not recommended for natural crotch rigging where the friction of the cover with the tree causes an imbalance in the load taken by the core and cover braids. Exceptionally strong, low stretch line that should only run over smooth sheaves or bollards. Hollow braid, such as 12-strand, is braided without a core. The number and diameter of the strands compared to the diameter of the rope determine if the lines are spliceable, abrasion resistant, and whether the rope remains round. Understanding the design and limitations of the equipment is an important part of setting up a safe and efficient rigging system. Tensile strength reported by the manufacturer is the breaking strength of a rope or piece of hardware. As a rope is used, its strength is reduced due to dirt, wear, knots, and loading. Cycles to failure takes into consideration the number of lifts and drops before a rope will fail. Larger loads reduces the number of cycles to failure. To increase the life of a rope, establish a working load limit, WLL, below the tensile strength that workers adhere to. The design factor or safety factor is the tensile strength divided by the WLL. For arborist rigging with dynamic loading, high wear, and dirty conditions, a design factor of 5 or greater is chosen. For example, if the published tensile strength of a piece of equipment is 20,000 pounds, then the WLL will be 4,000 pounds for that tool. Various components of any rigging system have different working load limits to consider. Equipment selection for a given situation can make a job safer and much more productive, provided the science behind a given device is understood. Friction devices have some obvious control advantages over taking wraps around the tree or using bollards. Rather than tying a knot each time a rope is used, connecting links such as carabiners, shackles, or screw links can speed the process. Use steel connecting links to handle heavy loads, high loading cycles, and dynamic loading. Carabiners must always be loaded along their major axis and never across the gate. Compared to running lines through tree crotches, blocks can decrease dynamic loading, rope wear, and tree damage. Remember that the load at the point of block attachment can be double the load in the rigging line. Arborist blocks are heavy-duty pulleys with large rotating sheave for the lowering line and a smaller sheave to accept a rope sling. Rescue pulleys are designed for static, overhead rigging where loads are known and very low friction is required. Pulleys require a separate connecting link to secure them to the rope, slings, or other equipment. Fundamental rigging techniques have options available to maximize productivity while still maintaining safety. Challenge: natural crotches can be fast and effective, but the running rope can injure the tree. Option: false crotches offer consistent friction and versatility of placement. Challenge: wrapping the rigging line around a tree trunk will work, but the amount of friction added is inconsistent and the wear on ropes and trees can be excessive. Option: friction devices offer alternatives to these drawbacks, plus they can help in raising wood. Challenge: controlling the swing is important for the safety of the climber and surrounding property, but piecing out a large limb by butt tying several sections takes time. Option: using a more complex technique, tie at the tip or butt and drop as one piece, or tie so it is balanced and lower it to the ground.